All right, this is a lesson on slope-intercept form using this handy-dandy Foldie that we will glue into the notebook when we're done. Let's go ahead and look at the first flap and get started. I'll zoom in here. It says identify the slope and the y-intercept in each of the graphs below. Compare it to the equation of the line. What do you notice? So on number 1, it says the graph below represents the linear equation y equals 3/5 x minus 2. So we know how to do slope. There's a couple of points marked here for us. Let's go ahead and do that. So going from this point to this point, my rise is 3, and my run is 1, 2, 3, 4, 5. So my slope is 3/5. Now the y-intercept is where the graph crosses the y-axis. So this is our y-axis, and if we start at the origin and count down 1, 2 to where it crosses, we see that that's -2 on the y-axis. So our y-intercept is -2. So looking at our equation, 3/5, our slope is in the equation, and that's next to the x. That's the coefficient of x. And then we have -2 here on the end, and that's the y-intercept. So you can see that the slope and the y-intercept are right there in the equation. All right, let's take a look at number 2. The graph below represents the linear equation y equals -1/2 x plus 3. So if we're looking at the 2 points they give us to do slope, these will be going down. Notice the line is going down, and so it looks like it's going down 3. So my rise is actually a fall of -3, and then the run is 1, 2, 3, 4, 5, 6. So when we do the slope, be -3/6, which should reduce to -1/2. If we divide the top and the bottom by 3, we get 1/2. And so if we look at our equation, it happened again. The slope is the number with the x, the coefficient of x. And then the y-intercept, where it crosses the y-axis, is at 1, 2, 3 up from the origin, +3, and that's this part of the equation right here. So when we're looking at the equation in slope-intercept form, it gives us the slope and the y-intercept, which is enough information to make a graph. All right, so if we go down here to this part, it's just showing us the general form of y equals mx plus b is the slope-intercept form. So m is the slope, and we use an m because originally this was done by someone in Europe, and I believe it was French. They used this word montar, something like that, which is like mountain for slope. And so in another language it started with an M, and basically that's why there's an M there. And the slope is always in front of x. It's always with x. Even if x was over here, the number with it would be the slope. B is the y-intercept, and when we do our graphs, that's going to be our beginning point. So B for beginning, that's how I think of that. So anyway, this is the slope, that's the y-intercept. Y equals mx plus b is the formula that we're going to be using for this lesson. All right, let's turn to the next flap. So if we look at example 1, what they have done is they have given us the graph of a line. Let me just zoom in a little bit here. And we are going to find the slope and the y-intercept and use that to write the equation for the line in slope-intercept form. So they've given us lots of points here. We can just start over here and figure out the rise and the run. So the rise looks like it's 1, and the run is 4. So remember that slope is rise over run, so that would be 1/4. This was our rise, and this was our run. It's important that you do the up and down part on the top, and the side to side part on the bottom when we do slope, which we've already talked about. If we look at where it crosses the y-axis, it's crossing at -3. So if we're going to write our slope-intercept form, you always start with y equals, and then the slope goes with x, so we do 1/4 x, and then the y-intercept is -3, so we put a -3 on the end. You could also do plus -3, but it's just a little simpler if we just use -3. So that is the equation for this line. And you could use this equation to find any point that you want to. You could put in all kinds of x coordinates and find out what the y coordinates are, and we could find all the different points that are on this line. Okay, so let's go over and take a look at number 2. See what that has for us. So the first thing we're looking for is slope, which is our rise over run. So this line is going down, so immediately I'm going to put a negative on here. That way I won't forget to put it on my answer. The line's going down, I know it has to be negative. So starting at this point, see how far it's going down. It looks like we're going down 3, so we represent that with -3. And then we're going over 1, 2, 3, 4 boxes, so that would be +4. So my slope would be -3/4. Y-intercept is where it crosses the y-axis. So here's my y-axis, and it's crossing at +1. So that would be my y-intercept. So when we go down to do slope-intercept form, we start with y equals. That has to be there, or it will not be correct. And then we do the slope, so -3/4, and that goes with x. There has to be an x with it. And then the y-intercept is +1, so we're going to use a +1 to tack that on the end. If it's positive, you use a plus. If it's negative, you use a minus. Okay, let's go ahead and look at number 3. So let me slide that up here. So on number 3, I notice this line is also going down. We read it from left to right, just like we read sentences. And so I'm going to put a negative down here automatically so I don't forget. So let's just use this point and this point. You can use any 2 points you want. So it looks like it's going down 2, so that would be -2. And it's going over 1. So my slope is -2/1. And we usually go ahead and simplify that down to just -2. You take 2 and divide by 1, you get 2. And then the slope is negative. So that's my final answer. The y-intercept, if we're looking at where it crosses the y-axis, it's up here at 1, 2, 3, 4. So my y-intercept is 4. So my slope-intercept form, you always start with y equals, then you do the slope, -2. That goes with x. And my y-intercept is 4, so we do +4. So that's it for number 3. Moving along, I'll do the last one of these, number 4. I notice this is going up, so I know my slope is positive. Just kind of keep that in mind. I'm going to start from this point and go to this one. So my rise looks like it's 2. And my run over this point is 1, 2, 3, 4, 5. So my slope is 2/5. And if I could reduce that, I would. Just for the sake of argument, let's say I'd use this point and this point over here because I didn't notice this one. If I had done that, then my rise would have been 4 and over 10. But 4/10 would reduce to 2/5. And so you would still end up with the same slope in the end. You can use any 2 points that are on the grid lines where they cross. And they usually will mark these out, but if they don't mark them, then you just have to figure out some nice points to use where they cross the grid at nice numbers. All right, so the y-intercept is right there at the origin. It's crossing right there in the middle, so that is 0. So when we go to do our slope-intercept form, it would be y equals 2/5 x plus 0. Usually they'll leave the 0 part off and just do y equals 2/5 x. Let me scoot that up so you can see it. So this is what they're usually looking for. It's not wrong to do the plus 0. It's just extra writing. And so if you ever see anything like this where it's got a slope, it's got the number in front of x, but it doesn't have any plus or minus number here on the end, you'll know that that line goes through the origin at 0. Okay, so that's how we write equations using lines that are already drawn. The last thing that we're going to look at is graphing lines using slope-intercept form. All right, so we've got a little step-by-step guide here at the top. So step 1 is to plot the y-intercept, which is the b. So if you're looking at your equation, the y equals mx plus b, it's this number right here. So you're going to put that on the y-axis. Step 2 is to plot the slope, and we're going to say as many points as possible. We're just going to go all the way across the graph. And then step 3 is to connect the points, and theoretically you should use a ruler to make it a really nice straight line. And we're going to put arrows on the ends. So those are our steps. I'm going to pause for a second and find a ruler while you guys are writing this down. Okay, if you need more time, then we'll need to pause the video. I don't want to make this video too terribly long, so if you need more time, go ahead and push pause. I'm going to go on down to the first example down here. All right, so it says example, graph y equals 2/3 x minus 1. So on step 1, up here it says we're just going to plot the y-intercept b. So we need to find that first. That is this number right here, and you include the minus sign. That is the b. That is my y-intercept. So that means if I go over here to my y-axis, that's where my point is going to go at -1. So I'm going to put a point down here at -1. Then step 2 says we're going to plot the slope. So my slope is 2/3. And remember that that's rise over run. So the 2 means you're going to go up 2, and the 3 means you're going to go right 3. At least that's how we're going to start. So if I go up 2 from that first point that I did, I'm just going to scoot this over. So go up 2 and right 3, I can put a point right there. And we want to do as many as possible. So starting here, I'm going to go up 2 and right 3, and we've got that. Now we can continue that pattern to the left. We could go down 2 and back 3, down 2 and back 3, and that also works. So why does that work? Well, it's because if I went this way, down 2 and left 3, the negatives cancel and still give you a slope of positive 2/3. So if you see, the slope is still positive, it's still going up. It's just that we reversed both of the directions, and that gives us some more points. So we can take our ruler, put it up here, connect the points. I didn't do a very good job of getting it through the points, but you get the idea. I'm trying to do this sideways while on video. videoing. And then on the ends, we put arrows because lines go forever. That is a part of the geometric definition of a line, is that it is a set of points. They have a certain slope and they have a certain y-intercept, but they go forever. We could make this graph bigger and just keep doing points and doing points and doing points, going up 2 over 3, up 2 over 3, or down 2, back 3, down 2, back 3, as many times as we wanted to. And so those arrows are very important. They need to be on your answer. Okay? When you graph these, you must have arrows. You must connect the points. You must have arrows. All right, let's go ahead and go down to the examples that are down here. Let me zoom in on example 1. All right, so our first thing that we do is we find the y-intercept. So that's right here. That's my y-intercept. That's my beginning point, my B. And so if I go to the y-axis, which is the one that goes up and down, I'm going to go down to 1, 2, 3, 4, -4, and that is my beginning point. Then we plot the slope. So my slope is 1/3. And so when we look at the 1 and the 3, the positive 1 means go up 1, and the 3 means go right 3. So we're starting from this point we already put on the paper down here at -4. And then we're going to go up 1 and right 3, up 1 and right 3 until we run out of graph. And we can also reverse it, go down 1, left 3, down 1, left 3. And this should make a straight line. So if you've reversed that correctly, they'll all match up. And I will use a ruler to draw a nice straight line. And then the last step is to make sure you're putting arrows on there because lines go forever. If you leave those off, it's really a line segment, which is different than a line. It's just a piece of a line. And we want to show that this is the whole line. This equation represents points that go on forever in both directions. Okay, let's go over to number 2. So our first step is to find the y-intercept. So our y-intercept, our beginning point, our B, is at +3. So starting at the origin, we're going to go up 3. That's where that point goes, on the y-axis, because it's a y-intercept. And then my slope is -5, and we're going to have to turn that into a fraction to do rise over run. So -5, to turn that into a fraction, we make it -5 over 1, because it doesn't change the number, it doesn't change the number at all, but it does make it a fraction. So the -5 means we're going to go down 5, and the 1 means I'm going to go right 1. So starting from this point we already put on the graph, I'm going to count down 1, 2, 3, 4, 5, and right 1. And then we're going to run out of graph, but I'll do another one. Down 1, 2, 3, 4, and then I'll just pretend down here is 5, and then over 1, like that. And it doesn't look like we're going to be able to do much above the graph. You could extend the graph to go up 5 and back 1 if you wanted to, but we've pretty much filled up the graph, so we're going to call this good. We've got at least 3 points on there. And then we're going to make a nice straight line and put arrows on the ends. Can't see my arrow. There you go. So I put arrows on the ends. Okay, let's go down to number 3. So, looking at our equation, we start with the y-intercept, or B for beginning, is +2. So I go to the y-axis, I go up from the origin 2 points, and put a point. We always start at the origin for the y-intercept. Put that right there. Now, there's no number in front of x. When that happens, we have to remember that x is the same thing as 1x. And so my slope, if I turn that into a fraction, it's going to be 1 over 1, which means I'm going to go up 1 and right 1. So I'm going to go up 1, right 1, up 1, right 1. We can do that a whole bunch of times. Up 1, right 1, up 1, right 1. And then we can reverse it, down one, back one, down one, back one, down one, back one, so that it stays a nice straight line. And I want you to put as many points as you can. Just continue that pattern. That way we'll have this nice straight line, and then we will connect the points and put arrows, just like that. So this is a special case. Whenever you don't have a number in front of x, that means that the slope is 1. So if we want to put a little note over here between number 3 and number 4, x is the same thing as 1x. So your slope is 1, or 1 over 1. And then if they give you a negative x, which is another situation that sometimes happens, that's the same thing as negative 1x, and your slope is negative 1 or negative 1 over 1. And in that case, you'd go down 1, right 1, down 1, right 1. So it's just a couple of scenarios that can happen that are sort of special cases. Okay, pause. If you want to write that down, I'll let you have a little time to do that. Okay, if you need more time, you need to pause the video. I am going to move on to our very last example, number 4. Get it up here on the screen. There we go. It says graph y equals 3x. Well, we're supposed to start with the y-intercept, and there's nothing over here. So remember, when there's nothing over here, that's the same thing as plus 0. So that would be my y-intercept, my beginning point. So that means we're going to start at the origin on this one. And then the slope is 3, and we can write that as 3 over 1. Anytime it's a whole number, we're just going to put 1 underneath it. And so that means we're going to go up 3, and we're going to go right 1. So we're going to go up 3, right 1, up 3, right 1. And then we can reverse it, down 3, back 1, down 3, back 1. You can always reverse it and just make sure that your line is still going up. And we'll put our arrows on the ends. Kind of ran out of room up there. I'm going to put my arrow right there just to show that it goes forever. And that is the end of our lesson. You can always go back and watch this again, get pieces of it if you missed something.